In this video, we will be solving rational inequalities by using their graph. So example 1 says solve the inequality r of x, and you can see your r of x here is less than or equal to 0. This is again in function notation, simply telling me when y is less than or equal to 0. And it tells me where r of x equals 5x plus 5 over 3x plus 6. We're going to solve this by using the graph of the function. So because it is when r of x is less than 0 or when y is less than 0, that is everything down here. And actually, let me cover it the other way. This is this portion of the graph. This is when your y is less than 0. Everything up here is when y is greater than 0. So the portion of my graph that is less than 0 is this right here. And so it is only this little portion here. Now, even though this is less than or equal to 0, and specifically that or equal to, you have to be careful with your brackets and your parentheses. When I go from left to right, this is going down right here. And that doesn't, usually arrow means forever, right? But this is getting closer and closer to this dashed line. And we know that these dashed lines here represent asymptotes. We also know that what an asymptote represents is that this line is going to forever get closer and closer and closer to this asymptote, but it will never ever touch it. It will never ever reach that asymptote. So even though this is less than or equal to, the answer here is -2, because it's never going to actually reach to that -2. And then the biggest x value is right here at -1. And it does actually touch that -1. So -1 is with brackets. When you are approaching asymptotes, it's always going to be a parenthesis, whether this is greater than, whether this is an or equals to or not. And then your zeros will still be brackets. Okay, so be careful with that. Now, this is all we have to do, but I want to show you something for when we go to the next portion and have to solve these algebraically. These two numbers I can reach by looking at my function. So the first thing that this function here tells me are my zeros. And your zeros come from the top. And so when I set 5x plus 5 equal to 0 and solve, I'll subtract my 5 and divide by 5, and I get that x equals -1, which is right here on my graph. And then the bottom part of these functions, of these rational inequalities, tell me my vertical asymptotes, and we get that by the bottom. So we'll set 3x plus 6 equal to 0. Subtract your 6 to get 3x equals -6. And then divide by 3 to get x equals -2, which is exactly here where that vertical asymptote are. So when we solve it algebraically, this is what we're doing. We're finding the zeros and we're finding the vertical asymptotes. Okay, number 2. State the solution set of the inequality x minus 6 over x minus 8 is greater than 0 by reading the graph. So because we're greater than 0, that means everything here above my x-axis. Here, they all have y values that are greater than 0. So we are talking about this portion, and we are talking about this portion here. So how do we represent this portion right here? That is negative infinity to 6. And we get parentheses because it's simply greater than, it does not include 6. Because we have our two portions, we have the union. Then this, it's approaching this vertical asymptote right here at 8. So this 8's going to get that parentheses, whether this was greater than, or even if it was greater than or equal to, it still would get parentheses here because of that vertical asymptote. And then it's going to keep going forever in the positive direction. So this is my answer to this graph. That was the answer to this graph right there. Okay. Again, this is all we have to do for this because we get to have the graph and the graphs are nice, visual, and easy. For practice though, the two things we need are zeros and vertical asymptotes. To find your zeros, you take the top of this and set this equal to 0. In this case, we would add our 6 over. And we get x is 6, which is what this graph is showing. Find the vertical asymptote, now we care about the bottom. And we'd set the bottom equal to 0, add your 8 over. And we have a vertical asymptote at 8, which is, again, exactly what this graph is showing. This is what we got to do on the next video. Here, use the graph of the function f to solve the inequality. So the first one I need is when f of x is greater than 0. Okay. And we remember that this is just another way to say when y is greater than 0. So when f of x is greater than 0, is everything here above my x-axis. That is when my y values are greater than 0. So we are talking about this portion. And we are talking about this portion. So when is f of x or y greater than 0? This is negative infinity. And then it's approaching this asymptote here at y equals -1. I have two portions here, so we'll connect it with the union. And then we go from 0 to it's approaching an asymptote again at 4. So 0 to 4. Okay. And again, this -1 and this 4 would have parentheses here, even if this was greater than or equal to 0 because of the asymptotes. Okay, so then part B, when f of x is less than or equal to 0. And this is again just another way to say when y is less than or equal to 0. So now this is everything below the x-axis because this is when my y values are less than 0. Be careful with this or greater than or equal to portion for when we have asymptotes. This portion here starts with an asymptote at -1. So -1, 2, and then it comes all the way up here to 0. And 0 gets the bracket. No bracket here because of the asymptote. A bracket here because of the point. We'll connect our two portions by the union. And then we have 4 to infinity, which are both going to get parentheses. Parentheses here with the 4 because it's approaching an asymptote. And then infinity always gets parentheses. Okay, so even though This is less than or equal to, we only have one bracket here. So you have to pay attention to those asymptotes versus points.